Good morning. It's a pleasure to be here, and thank you. Thank you. And thank you, Harold, wherever he ran to, and Mark for all your help in getting things organized and set up. So now that you almost fell asleep during that introduction, the number one question that I always get asked is, okay, I heard all that, but I still don't know, how did you get into the industry? And my simplest definition is every time you hold up your phone and you're on Google Maps and you want to go somewhere and you hit satellite map, you're going to see Landsat. I got into the industry because I was able to get into a group of people from where I worked at General Electric. They had GE Aerospace had just won a contract with the US government to commercialize space and to educate the world in remote sensing. And that was literally the two missions that the organization had. They had that because a public law had been passed under the Reagan administration. It was called the Land Remote Sensing Policy Act. And as an olive branch to the rest of the world, and mostly to Russia, because we had come through a pretty serious nuclear conflict and event that had people ready to press the button again, as late as 1983, and that's been published, so you can read about that. The countries came together, and as always, there's in the Department of State an olive branch is extended. And part of that olive branch was actually the Land Remote Sensing Policy Act, which commercialized a satellite called ERTS, E-R-T-S, the Earth Remote Terrain Sensing Systems. You now know that as Landsat 9. My job was to travel all over the world to all the ground stations and all of the major government entities and move the system from being a government classified system to a commercial system. Because people said, how did you get all the experience? I said, well, when you're standing at a ground station and they're moving equipment and the guy next to you has a gun, you learn things really fast and as best you can. So I helped move those systems into commercial systems. So I stood up 16 more ground station with a team of we were small, we had 10 people. There were probably 100 people in the company at large. We moved all the systems from NASA and NOAA to a building in Silver Spring, Maryland. And we moved everything from a room bigger than this to running the actual satellite off of laptops. And we changed the way the ground stations operated and went into real commercial operations. So I put together the ground station network and then a data distribution network. We took the science community by all these ground stations because the only way we could figure out how to actually commercialize remote sensing was to find where those pockets of expertise was. And believe it or not, we started in Norway. So you'll see some things here from Norway. I have deep expertise in Norway. Norway had a lot of technical expertise then in GIS and more in remote sensing than just about any other country in the world, because they had stood up some of the first radio receiver, transmission and receiving stations. And then they became one of the largest ground station networking groups in the world. They literally cover the world. And they're also our first point of contact when any satellite is launched, and NORAD communicates with them. So I was very blessed to work in that kind of environment. And because I was working in Norway so often, getting the ground station model really stood up, I was able to learn more about the energy industry probably than you could have anywhere else. That was their client base. It's 80% of their GDP. And it was almost like being in the United States because so many United States energy entities were also in Norway. So that's kind of how I got into the business. When GE Aerospace sold to Martin Marietta, which then merged with a little company called Lockheed, and then became Lockheed Martin Enterprise Integration Group out of Philadelphia and DC, Valley Forge, Philadelphia. That's where the bus and the sensor were actually made for Landsat before they took it over. And once they took things over, they had decided they were going to get out of the commercial space. And I had just spent a decade building that space. And I really believed that the commercial side of the equation was going to grow bigger than the government side. So I was finishing my PhD and I went in and chatted with people and they said, oh, well, we don't want you to leave. I said, well, what am I going to do if you're only going to do government? Because they really wanted to build billion-dollar birds. And the pricing mechanisms and the cost was just plummeting because more and more commercial organizations and academic research areas were standing up small sats, light sensors for airborne, light sensors for terrestrial networking. So I really said, I don't have a choice. I have to stay on the commercial side. And they said, well, we don't want you to go. And I said, well, I'm going to stay in the industry, but I wrote a business plan and this is what I want to do. And they said, well, how can we help you get started? My bosses at the time, who when I first met them, I knew them as Jim and Jeff. Jeff was the Honorable Jeffrey Harris, the director of the National Reconnaissance Office. And they had come out into the rest of the world, so we were finally allowed to say that. And then my other boss, Jim, whom I promptly put in his place during a board meeting when he told me I couldn't have cell phones for my regional sales representatives. And he told me an umbrella and a roll of quarters would work well. And I'm like, a roll of quarters? Where are you from? And I said, clearly you haven't had people in harm's way. So, you know, I think I need the cell phone and quit talking to me about umbrellas. So I finished my board presentation and I walked out of the room and a bunch of people that I work with came running after me telling me, oh my God, you're fired probably. And I said, why would I be fired? They said, do you know who you just said that to? I said, yeah, his name is Jim. He's on the board. They said, that is General James Clapper, Colonel at the time. He was Colonel James Clapper at the time, and he became our Director of National Intelligence. He became the Director of the National Geospatial Intelligence Agency. I got called back into the room, and he said, hey, that was the right thing to say to me. I just wanted to see if you had any guts. I said, guts, I have plenty of. Brains, sometimes not so much. So that was my boss. He said, what can I do to help you get started if you're not going to stay here? I said, I'd like the database that I built. Can you sell it to me? They sold me everything I needed to start Global Marketing Insights for $1 in a technology transfer agreement, thus why I was finishing my degree in tech transfer. And that database is now 1.7 million contacts of geospatial, GIS, and market domain sectors. So I spent most of my time in the critical infrastructure area because that's really where Landsat data and airborne data really belonged, and all of our cores networks and our water gauges. So I worked across all the sensors. I will say I also worked mostly upstream at the time because the data were really used for exploration. It wasn't until more mid of my career we focused midstream and now downstream all the time. So that's my background. That's where I came from. Today we're going to talk about 5 points. Who's my timer that's going to tell me 5? Good job. Thank you. I need it. So I'm going to hit on these 5 points. You know, what do I mean when I say critical infrastructure energy? Why is digital twins on everybody's lips? What are some successful business examples where people are really making a big difference in the world? And why is it important to our business and our country? As well as, how do you combat critical infrastructure threats? And those of you that have heard me speak before, raise your hands. Yeah, see, there's a few of you. You know I'll talk about China, so just don't roll your eyes when it happens. So creating digital twins, I will tell you, the first thing, when Harold interviewed me, I said, first of all, GIS, geospatial, we have been digital twinning since it was created. So that can be some new set of buzzwords, but that's really what we have always done. We have created digital twins, always. And there's a lot of controversy. Just look up, where did digital twins begin? Google it or do chat, and you'll see that usually what comes up in the first top 3 selections is the Apollo 13 mission, when we had trouble with the service module. And the reason why I like to show this example is because of that, this simulator. This simulator is what was used when they were actually doing taking their modeling with duct tape and everything else, and then they would run it through a simulator. So unlike the movie where, you know, like they make it look like it was really just duct tape, it was not just duct taping going on. They took everything they did, they ran it through a massive simulator, and then they modeled what the results were. Now, NASA and the NASA works at what we call 7 nines, 99.99999% accuracy. I work with a group of people that like 100% accuracy, and you know how hard that is to get to because we're the ones that are always looking at the covariances and the models and the statistics. So you can imagine the simulator wasn't spitting out such great news, but they didn't have much of a choice. But that simulator, the power in that simulator with all the robots that were in there, we could probably run it off of a laptop today with less memory and storage capacity and RAM on it than they had right there. So they were really chugging along. There's another example, and the reason I have 1940 up there, there are several examples of digital twinning from both World Wars, but particularly World War II. There's a project, if you want to look it up, it's called Project Amsterdam. And you'll be fascinated by it, but it's really depressing because the outcome was, so I don't show it because inevitably people say, how'd it go? And it went badly. A lot of people died and were tortured. It's a horrific story, but it's truly as far back as I could go. It is a digital twinning model using GIS maps, and it was critical infrastructure energy. The Germans were taking over, they took over a hydro power plant in Norway. So again, here we go with the Norway thing. They took it over in Norway. It was being run by the Nazis. Great Britain wanted to take out the power plant. The power plant, because of its water capability, large volume water and a certain type of water, it was going to be used for their nuclear reactor program. And the goal was to take it out to stop the advance of Germany towards nuclear weapons. And as I said, it had horrific outcome for the Allies. However, it is one of the first example of digital twinning, mapping, GIS capabilities, and much more so in the planning phase and the delivery. And remember that they were flying World War II equipment at that time. But it was really a digital twin model. That project did not go badly because of what they were doing. It went badly, believe it or not, because of weather. They got caught in terrible weather, and they used gliders. So they were using gliders at a time when it was really a new technology. And believe it or not, there were sometimes 4 and 5 individuals in those gliders. But it was a digital twin. It was a computerized model for the computer technology that they had at the time. So I vote 1940, but you can weigh in when you look at it. So when I talk about energy, I always talk about critical infrastructure. So I work with the National Geospatial-Intelligence Agency on a contract with NATO. I'm a subject matter expert for commercial data on infrastructure, critical infrastructure. It's a cooperative research and development agreement, so you might have heard of CRADAs over time. And so the CRADA holds my capability to do that work with NATO at NGA, and the people that run that contract are L3 Harris. The definition of critical infrastructure that I like the most is by CISA. Now, CISA is an agency that's the Cybersecurity and Information Security Agency. They sit under the Department of Homeland Security. And it is the definition by which we look at critical infrastructure now. I spend most of my time down here in this bottom part of the critical infrastructure world, and they're all very closely tied together. I started out in food security because Landsat ERTS was actually developed to protect us from ever having another great grain robbery. So if you want to look at another really good book, look up The Great Grain Robbery from Russia in 1972, long before my time in the industry, but it's what created ERTS, which now you know is Landsat 9. And that satellite was multispectral. We did not have multispectral satellite technology at the time, and that's how ERTS, or what we would know as Landsat 1, was created. And it was used for global food security, to analyze crop yields globally, and to look at water resources globally. Nowadays, I spend equal amounts of time working internationally and US based. They don't ever talk about critical infrastructure without talking about smart cities, ever. And where I find most of the activity in smart cities is right now focused in Africa. There are several companies in our arena that you would recognize that are spending a lot of time there because they're bypassing all of the true legacy infrastructure capabilities and moving straight to digital infrastructure, digital transformation infrastructure. And the companies that I see the most in Africa, and we've been working on a huge project in Africa for the past year and a half, is Hexagon, Bentley, and Esri, and Wolpert. So Wolpert bought several, they bought a company, Southern Mapping, I think it's called, in South Africa, and they have a huge airborne network capability there in Africa. And it's amazing how much, when we get into the smart city environment there, and a company out of that you might want to look up because they are making inroads into the US as well as other places internationally. It's called Spatial Vision. Now, Spatial Vision is out of Australia. They focus in our space, but on smart cities. Very talented group of people, and they do everything from the planning to the implementation with a variety of partners. I always introduce people that are our clients or work with us to them if they say they want to do international work. New Zealand, Australia, Southern Asia, not very much in India, but Africa as well is where they're breaking into. Oil energy, this is an oil and gas example, but the government is deep into the energy market. That is no surprise to any of us. We've known that. They've always been deep into it. But they've published reports now. And once they start publishing reports, regulations, legislation follows. Try to warn everybody about that because it tightens up what we do, what we can't do. And they have taken every one of those critical infrastructure bullets that I showed on that other chart, and now there are reams of documentation. I like this one in particular. It's called Critical Infrastructure Risk Management, and it's about the energy global supply chain. And of course, why I like it is because the very first thing they list is remote sensing. So, and that's near and dear to my heart because it took us a long time to get people to understand what GIS, remote sensing, and geospatial technology really was, let alone for it to end up in a published commercial document as one of the very first things that they highlight. It's they included things they also really deem as important: very small aperture terminals, position, navigation, and timing, SCADA systems, and of course the Internet of Things, because that's where we see all our vulnerabilities. But there's some news, and this is also a point of great conflict right now, because that remote sensing, if I removed that box, it would say space systems. And now there is legislation afoot that says we want to put space systems as part of critical infrastructure. That would be a whole nother session that I would do with you. I taught classes in it at MITRE in Bedford, Mass. in August. They're talking about space systems and remote sensing systems as critical infrastructure. Well, you can imagine if it hits the CISA list of critical infrastructure under the Department of Homeland Security, you then have a whole different set of regulations that govern your activities, your sensing, just more boxes to check and more things to do. I believe there's always been a space system side of it in critical infrastructure. Now they're making it what I'd call open source space systems critical infrastructure. And we'll talk a little bit more about open source and open digital in a minute. But why is everybody talking about digital twins? I really couldn't get the gist of it when it first came out. I'm like, we've always been doing that. What? Just new marketing term. And it's always comes up as three things. There are threats in the critical infrastructure in energy. There are incidents that happen naturally due to equipment failure, and we in the energy world know those because there's maintenance issues, there's incidents where there's cracks in the pipe. There's so many things that can cause a vulnerability or critical infrastructure incident in the energy world. And there are vulnerabilities. Now, those vulnerabilities, I will tell you everything that they look at, they leave the daily maintenance and the routine of the energy industry, whether it's electrical, hydro, wind, solar, they leave the daily vulnerabilities to the owners. They really focus on what I call the digital vulnerabilities. Clients across the board in critical infrastructure for energy always want speed. They need their capability delivered in the way that they need it, and they want you to be agile, which is very hard for those of us that work with contracts and statements of work that have specific deliverables. They are constantly changing things and outputs the way they want them. We provide what I would call deep immersion into these topics because we can literally add in anything we want into GIS and see what the output is like. We have regional persistence, and nobody knows that better than people from Pennsylvania and Ohio with all the work we do in Marcellus Shell and everything that we've done long-standing in the energy infrastructure and critical infrastructure world. What I see out in the rest of the world where we're getting tested more often than not is hydrogen co-firing, new nuclear small modular reactors. But I'm telling you, I'm seeing changes in motors and robots, the miniaturization of those things, probably number one. When I go in, I get to look at things they're working on the true exploration, production, and development side. But what I'm talking about more than ever is robotics and motors, changes to that, and changes to compute processing and storage. And I mean massive changes where they're doing memory provisioning. I'm watching companies. I was in a meeting with an energy company, and the head of the project is a company called Cove, K-O-V-E. You wouldn't know it. You would know, though, the group that runs our ATM system worldwide. It's called SWIFT. Cove created the SWIFT memory provisioning system, and they can take a room full of servers and they can provision it down so that I could run it off of something smaller than this. I could literally run it off of a handheld device because of the way they do memory provisioning. And so compute processing and storage, why? Because it saves on battery, it saves on power. And that's the very first thing they show you. Use our system, and this is what happens to your electric power consumption. This is what happens to the extension of your battery life. And they're processing, with the SWIFT system, 1.3 trillion transactions an hour. So, and again, Cove, you're like, okay, but SWIFT and ATM, it works no matter where we go, and it's transmitted, it matches your bank account, it matches it to US dollars versus wherever you are. they started off when they built the system. They said, yeah, well, we don't know what you call it. Everybody calls it digital twins, but it's immediate modeling to reflect a digital, a physical environment. And that's still what they do today. What I like is to talk to people that are really doing the real work. I was, where's Michael's? There's Michael. I was talking to Michael about, the difference between where he was and where he is now with Locana. And those stories are really valuable because that's where I really discover what is truly happening with digital twins. This is a gentleman. He says, well, don't use my names. Just say I'm an executive. And he was with the New York Power Authority. And what they were doing is they decided they were going to run hydrogen in their gas turbine. And they said, hey, what we saw is the gas turbine didn't care that it was hydrogen. And we stayed within our operating permit for NOx. We lowered our CO and we maintained the same ammonia output. But here's what was so important. He said, we use the digital twin technology to replicate processes in a virtual environment before we do them in a real environment. And that's unbelievable cost savings. And he gets lots of pats on the back because he's not spinning up expensive equipment for a test that inevitably that test failed. But the failure cost this much versus this much without the digital twin. So that's why they're using it. Successful business examples. This was something Harold asked me to do. He said, can you show us some unusual, successful business examples that we might not see otherwise? So, and this is where I go to my notes because the people I got the example from asked me not to misquote them because they said I'm so marketing oriented. I went, oh, okay. So I have my trusted notes. And it's a company from Oslo, Norway. And it's called Cognite. They use something called an open industrial digital twin. It's really important because it's the basis for everything they build their digital twinning off of. But if you talk to their clients, they talk about the exact same things, and their clients are Royal Dutch Shell. You name it, they have oil and gas clients, electrification, energy clients as well, and hydro clients. In fact, that dam from the 1940s example, Project Amsterdam, is still one of the largest hydro dams in the world, and Cognite works with them. What I like about them is the way they think about everything that goes on in the client's environment. And I'm going to talk about this box right here a little bit more, but I'm going to break it down and make it a little bit easier to go through and to understand. But it's a conceptualized industrial base. And I strongly emphasize conceptualized industrial base. But that's where all of their AI and machine learning works. And their outputs are specifically designed to what the customer wants to see in terms of operational insights. And they use something called an industrial knowledge graph. These are common terms, but what they do when they build this capability is not the usual, especially in the United States. In fact, it's not really the usual in other parts of Europe as well. So they want to have what I call hybrid AI. Everybody talks about generative AI. That's the big term here. They call it what it is. No AI is 100% satisfaction guaranteed. So they use a hybrid of experts. So you're sitting in a room like with all of us. So they have experts that look at the data, and then they have their AI and their ML models. And that's why they call it hybrid, because they don't believe that anything is really generative unless it's for research only. And they said, and we're not a research institute, we make money by making sure we provide an operational insight to our client. And so their key focus is on taking in raw data, open source raw data related to the assets of the client, and then additional data sources that enable and drive their interrogations of the industrial data. They use large language models. So not Chat GPT, they actually use large language models. They have astrophysicists employed on their team. So it's funny, and I always review a presentation for an audience with someone that's going to be in the audience. So Ed, raise your hand. Ed got to be the guy that, he didn't see the notes, and he sent me back a note that said, wow, this is Monte Carlo simulation on steroids. And by the way, you need to tell them astrophysicists are taking over the world. And it was, and I had to laugh because nowhere in here does it say astrophysicists, but that's exactly what they did. They brought in large language model developers who were astrophysicists, and there is an abundance of them. If you just look, there are probably more astrophysicists in Pennsylvania than you ever dreamed of, and they developed these large language models. Now, this conceptualized, now I'm going to read from my notes so I don't mess up here. They build it, but they were processing to improve the quality through normalization, scaling, and augmentation for calculated, or what I would call aggregated attributes. There I am putting my own words in. But their belief is there's always garbage in and garbage out to some degree. So you have to have that hybrid AI expert sitting there, and don't ever take them out of the equation. And the aggregations of industrial data in large data warehouses and data lakes, they really believe they have not been contextualized or pre-processed. And they weren't done, that wasn't done because they didn't have those semantic relationships, large language models. So they're employing large language models, and you don't have to, as a client, you don't have to take in that capability. You can just use the regular data and they'll do a regular output. That's option 1 on their product delivery. They call it option 1, an open industrial digital twin. We'll use whatever data you give us, we'll use whatever's out there that you want, and we'll produce this capability. But option 2 for them, and that's where I see Royal Dutch Shell and the big guys all heading, and the same with the electrification groups as well. They want to see how those large language models allow them to get prompts. A question is a prompt, and then you provide it with additional information, which is all of our information, and that large language model spits out capability that provides real-time data on the equipment, deployments, optimization of maintenance. It's really interesting. What I see on the client side is cost savings. They want cost savings. The provider side, our side, we want to make profit, but they're always looking at cost savings. They access data from multiple repositories, not dissimilar to what we do in the United States, but I will tell you, they keep it in a way that it's continually refined. And those large language models help them do that. They did something really unique and that I thought was fascinating. They brought in a plant, I would say more in the midstream area. Everybody was retiring. They had no maintenance manuals, and they had the gentleman record everything they knew about every piece of equipment. They fed that into their large language models and created an entire digital twin for maintenance. But they did it because they knew they would never be able to train the new people. So they literally they had one person that did his recording. He was 80 years old, and he had worked there since he was 20 years old. And he just said, you got to find somebody else to do this. And they were like, well, how's that going to happen? And they interviewed him over a period of 4 days, used a large language model, and created that maintenance record. So I'm going to move to another company. So get ready for everybody that's heard me speak before. This company is called Supermap. They have 4,000 employees. They have 10,000 clients. They use something that I would call an open industrial digital twin. I have question marks there because I would say to you, is it really open? Because guess where that company is headquartered? And if you sign an agreement with China anywhere in the world for any capability, you have now signed away the data rights to all of the data that you collect financially, all the GIS and geospatial data. So read the small print, because it says in there that everything you give any Chinese original equipment manufacturer or value-added provider goes to the Chinese National Intelligence Services. This is the Gartner hype cycle, and why I think it's important. It shows that, you know, where we are in this moment in time, we're on the part of the hype cycle that gives us the kind of the slope of enlightenment. But here's good news. This is the GIS Gartner hype cycle for AI, and we're right at the cusp of making profit. So we are on the plateau of productivity. If your company is not involved in this area, I strongly urge you to start looking at it, because you need to. It is the way of the world, much more strong. I find it more prevalent in the rest of the world than I do here. Here's 3 other companies that are making great strides in digital twinning on the forefront, but they're Brazil. Rockwell Automation, we recognize, but their main operation for digital twinning, believe it or not, is in Mexico. Why is it important to our country? Well, for near-peer competitors and ubiquitous connectivity. That's what, when you see anything in critical infrastructure produced by CISA or DHS, they are always thinking about autonomous and ubiquitous connectivity. China, back to China, the velocity of China's online growth is phenomenal. We cannot keep up with it, We can't overcome it. So why do we spend time in it? It changes economics, the global deployment of 5G, AI, and persistent surveillance. Our data going over those networks is really important. It allows for infiltration at every technology level. We can have nefarious attacks, and it isn't a matter of if or how can you protect yourself. It's a matter of when it's going to happen, and it will happen. The reason it's going to happen, back to China, is Huawei and 5G networks. So every time you pick up your phone and you're looking for 5G, it doesn't really matter about 5G. That's just kind of another marketing ploy. What we're most interested in is sub-6, what we call sub-6 PAR technologies for data, voice, video. They own 80% of the world's surface in terms of original equipment manufacturers and distribution networks. So when you're in another country, you are using most likely a network that feeds back into China. And remember what I said, you sign a document that goes to the Chinese National Intelligence Services. It's truth. So what do we do about that? We focus on Industry 4.0. I love Industry 4.0 because it's moving us in a direction where we say, you know what, we can have the old manufacturing with the new. And we can have digital transformation and connectivity without losing any of the things that we already have famous in this country that we've built our reputations on. But I really like Industry 4.0 and test beds for innovation. And the reason I do is because everything that goes on, advanced automation, access and convergence, modernization of legacy equipment, making things smart, like our cell phone, you can turn a chiller or an HVAC system using an $80 dongle and Raspberry Pi. I can turn it into a smart system where it's giving me statistics. And there are facilities all over this country that will allow you to do that and to test out some capabilities in our energy space that you otherwise couldn't. It supports the warfighter because everything we learn and do in the commercial world does that. It is mostly centered around Industry 4.0 and 5G. It is to allow you to learn fast and fail fast. These innovation test beds are set up with the leading edge systems and connectivity so that when you move through them, you are not going to become tied to any one system because we can't afford it. We can't afford to go out and look at this in a way that our companies would even engage with it because you can't afford to bring all that connectivity to bear in one place. it provides you with, those of you that work in defense and military, it provides you with a way to look at digital twinning for a variety of military applications. We work mostly, I would say, in battle space situational awareness, sometimes on the logistics and transportation side. It offers you a way to look at virtual reality, augmented reality, robotics in a way that you never have before. And there are 15 Air Force, U.S. Air Force test beds that are commercial test beds that you can work in this autonomous and total system connectivity in 5G. There are 15 of those at Air Force bases. A little bit hard if you're not a defense contractor, but my top 3 picks are what you're going to see here. There's an organization in Rochester, New York called Stark Technology, critical power, energy and power, renewable power monitoring, Rochester, New York. Look them up, ask to go see them. Why do I want you to do that? You can go to these facilities. If you try to work with a university takes 55 to 57% of every project you do with them. It's just that's how they operate. So do the national labs, 55 to 57%. These organizations might take 5%. Maybe 10 is the most I've ever seen. They're there to move this country ahead on the digital transformation curve in ubiquitous connectivity. That's what they exist for. Cahomic is actually headquartered in Layton, Utah. So you can imagine they do a lot of really cool things with fighter jets and systems and the aerospace world. They have a lot of astrophysicists on staff, and you can go there and you can bring in a project and they'll tell you immediately whether or not you can do that project. Now, here, a couple people in here have been to 912 already. And I have one more slide. Thank you. Right on time. Because I talk fast. 912 is an organization. It's pretty unique. On 9/11, a gentleman in Indianapolis who was the chief of staff to the governor and had 2 Juris Doctor degrees, went home and told his wife, I enlisted in the National Guard. I leave in 2 days. And 4 kids. And his wife said, do it. And his name is Chad Pittman. And he is now full bird Colonel Chad Pittman. When he came back, he established a company, because what do you do after 9/11? Well, you have 912. And the mission is to innovate and provide a test bed so that our military and our Department of Defense could have the best of the best commercially. And he said those 2 worlds, when I was deployed, those 2 worlds never matched. And let me tell you, I've been in a forward deployed situation where we are literally holding things together with duct tape and paper clips, because that's sometimes how it works. Anybody in here that's served, thank you. It's a mess when you're forward deployed. And this facility, 60,000 square feet outside Indianapolis, why is it there? Most people don't realize Indiana has the largest landlocked Navy base in the world. It's called the Naval Surface Warfare Center. It's in Crane. There's no water to be found. It literally is the most landlocked base, naval base anywhere. And they created this capability in a place called 16 Tech, where they look at all of these capabilities. Ed Kuntz has been there looking at some really unique things that are done with sensors and ways to offload data. And this is how I close. So they make the Indy autonomous cars there. And this is a car that there are 15 of them. It is a university project. I met one of our recipients for the award, who she's going to be speaking later this afternoon. This is 15 universities from all over the world. They created an autonomous vehicle. When I say autonomous, there's not even a joystick. It is 100% run by algorithms. And so you can imagine the U.S. Purdue comes in with their 3 engineers, and Italy comes in with 30 engineers, because they're going to win. There was $1 million prize. These autonomous cars are driving today. They've been from Italy to Las Vegas. Of course, they started at Indy. They are run with Luminar LiDAR. What I love about this is the most modern digital twin I've ever seen. They go in, they run 3D LiDAR. They just did an open course. They map everything to 3D, and then those algorithms are readjusted by those individual teams, and then they race. And so the Italians, there were 2 Italian teams, and my favorite story is the one that should have won was leading the pack in Las Vegas. Hit 192.2 miles per hour around the track, and suddenly it pitted. Now, this is the group that had 30 engineers. For the test, they brought in 100. So here's 100 engineers racing over to the computers, looking through scads and scads of code and trying to find what the problem was. At the end of the day, a business guy from Italy came in, scrolled up to the top and said, "There's your problem." When it said laps, it was a 2-lap program. They had never changed it from the Indy lap, which was 1 lap. It pitted because the computer told it to, 100% autonomous. But why do I like to end with this example? In the military and the DoD side of the world, we live by a code of semper citius, which is always faster. We have to move ahead of the speed of threat in the energy industry. And thank you. Oh.